Right. Look at these nuts. Oh, jeez. Hey, ladies and gentlemen, boys and girls, children of various ages, all my math maniacs out there, what we're going to learn today is we're going to learn about how to classify quadrilaterals based upon the length of their sides and their angles. Now, you may be asking, what is a quadrilateral? Listen, a quadrilateral is a polygon with four sides. Let me show you some examples. A polygon with four sides. If you remember, a polygon is a shape made up of line segments, and it's a closed shape. So you can see that all of these examples right here are quadrilaterals. They have one, two, three, four sides. One, two, three, four. One, two, and we keep on going. And the types of quadrilaterals we are going to learn about today are right in between your eyeballs. They are the parallelogram, the rhombus, the square, the rectangle, and the trapezoid. And what you are going to see is this family of polygons, these quadrilaterals, they kind of have a personality. Each and every one of them have a personality of their own. I'm going to tell you about the personality of a square, the personality of a rectangle, the lonely trapezoid. So you guys are gonna learn the personality, not only what makes a square a square or parallelogram. You are also going to learn their personalities. Okay. So with that being said, I think it's pretty important that we understand what a pair is. Not the kind you eat, no, just a pair. It's like when you have a pair of shoes, your mom says, hey, get you a new pair of shoes. Your old one's worn out. Well, a pair is simply just two items that belong together. So when we are talking about a pair of parallel lines, what we are talking about is two lines. Okay, so I'm going to draw one, do the best I can just to stay on this line right here. So there's one line. That is one line right there. Okay, now if I draw another one right underneath it, do the best I can to stay on the line right there. That is another line. Guys, these lines will never ever touch. These are parallel lines. More important, this is one pair of parallel lines. So we're going to put a tick mark here and a tick mark here. That is one pair of parallel lines. Now, if I connect this right here, come on up, and then I connect this right here, coming on up, and these two now will never ever touch. They're going to go straight up or straight down, straight up and straight down. They will never touch if you let them go, you let them roll. So this is our second pair. I'm going to put two tick marks here. It's our second pair of parallel lines. Okay, so it's very important that we understand what a pair of lines are. Those are two lines. It's very important that we understand what a pair of parallel lines are, because that is what makes these quadrilaterals the name that they are. Now, let's get into some personality types. And like I said, each one of these quadrilaterals have a personality type. Let's start out with the square. What makes a square a square? A square has two pairs of parallel sides, two pairs, just like we saw before, two pairs of parallel sides, four right angles, and all sides are the same length. That's very, very important. All sides are the same length. Now, because a square has to meet all three of these criteria right here, all three of these things, it is very uptight. It is the most uptight quadrilateral that there is out there on this planet today. Everything has to be perfect. If it doesn't have the four right angles, the square gets mad because now it's not a square. If it doesn't have four equal length sides, it gets mad. If it doesn't have two pairs of parallel lines or sides, it gets mad. It's a very uptight quadrilateral. So you can see that this meets the definition of a square. All the sides are the same length. We have one pair of parallel lines right here. We have our second pair of parallel lines right here. Okay, and these are all right angles. These are 4 right angles. This is a very uptight quadrilateral, you guys. It needs to be perfect. And if it's not, it gets angry. Now, the one that is also uptight is rather here, the rectangle. Now, it's not nearly as uptight as a square is. It's a little bit more relaxed, let's put it that way. It's a little more relaxed because it only has 2 criteria that it needs to meet in order to be a rectangle. It only has 2 pairs of parallel lines. It only has to have 2 pairs of parallel sides, I'm sorry. And it has to have 4 right angles. Oh, I was on the wrong one. It has to have 2 pairs of parallel sides and 4 right angles. Did I just say that? Yes, I did just say that. Okay, so check that one off, check that one off, and then check that one off and check that one off. So a rectangle, you guys, can also be a square. Can be I'm going to put can be a square. Now, can a square be a rectangle? No, because a square has to have all equal sides. All sides are the same length. A rectangle doesn't care if all sides are the same length. Like I said, it's a little less uptight. So we can see that these are not equal sides right here. This pair of parallel lines are different lengths than this pair of parallel lines. So it's a little less uptight. All right, it's more relaxed. Now, a rhombus. A rhombus is definitely loosey-goosey. It really doesn't care about a lot of things. The only thing that it cares about is it has 2 pairs of parallel sides. 2 pairs of parallel sides, and all the sides must be the same length. Okay, so let's look at those attributes of, or that attribute of a rhombus again. It needs to have 2 pairs of parallel sides, and all sides are the same. Oh, there I go to the square again. I'm sorry. 2 pairs of parallel sides, and all sides are the same length. That's all the rhombus cares about. The rhombus doesn't care about right angles. It can care less if it's a right angle or not. If it is a right angle, does it still have 2 pairs of parallel sides and all sides are the same length? Yes. Does it have to have right angles like the square does? No. Okay. So we can see that these have 2 pairs of parallel sides. There's one pair, and there's the other pair. Now you can see right here that I see some obtuse angles. I see some acute angles. And like I said, it doesn't matter if they are acute, obtuse, or if they are all right. Oh, but since it has 2 pairs of parallel sides and all sides are the same length, could it also be called a square? Yes. So this time I'm just going to put square. Because it could also be called a square. Our rhombus can be a square. If these were all right angles, wouldn't they still have 2 pairs of parallel sides and all sides are the same length? Yes, but it doesn't care. This is definitely a loosey-goosey type quadrilateral. Now the loosiest, goosiest, the rebel, the family, the black sheep of the quadrilaterals is called a parallelogram. It really doesn't care about anything but itself. All you need to be, in order, all parallelogram has to have is 2 pairs of parallel sides. That's it. 2 pairs of parallel sides. Okay, so let's see. We come up here. Okay, we're gonna go to, there I go again. 2 pairs of parallel sides. Let me back this up a little bit. I see that with the square right there. So parallelogram, two pairs, that's it. So can a parallelogram be called a square too? Yes, because all it has is two pairs of parallel sides. It doesn't care if the sides are the same length. It doesn't care if they're different lengths. It doesn't care anything about right angles or if they're not right angles. I mean, this is a rebel of the group. It just doesn't care. It gets grounded a lot. It gets put out and put in time out a lot. It just doesn't care. All right. So we see, let's make sure this has two pairs of parallel. There's one pair of parallel sides. Here's the other pair of parallel sides. That's the only thing that the parallelogram cares about. That's it. Nothing else. It is a parallelogram. Yes, it does meet the definition, or it can be a square also, because as we see up here, two pairs of parallel sides, two pairs of parallel sides. Yes, that could also be called a square. Isn't that crazy? The square is just so, I don't want to call it selfish. It is, it just needs to be everything. Everything has to be perfect. It has to have all, it's so squared away. Get it? Okay, last one. Last one. The trapezoid. The trapezoid is the lonely quadrilateral of the family. Very lonely. Because it is the only quadrilateral that has one pair. It can only have one pair of parallel sides. If you notice, everything that we've talked about so far has two pairs of parallel sides. So let's look at our lonely trapezoid. There's one pair of parallel sides. So the trapezoid is a quadrilateral kind of by itself. One pair of parallel sides. And I like the little guy. I like the trapezoid. There's different types of trapezoids, but it's a bit lonely. So that's a difference between a square, rectangle, rhombus, and parallelogram and trapezoid. Now, some of you guys may be saying, hey, I got you. I got a question. I'm going to stump you. I got a question for you. What if there are no parallel sides and all the different sides are different lengths? Yes, there is such a quadrilateral like that. What if we get a quadrilateral that doesn't meet any of the definitions that you just taught us? Well, for now, we're just going to call that polygon a quadrilateral. It is a closed shape made up of line segments that has four sides. So that will be a quadrilateral. Now, there is a lot of different criteria that makes these shapes right here. And what I want you guys to do is take the notes, maybe pause. I'll put the definitions up there one more time. I can find them, and write down these definitions just like I did on the piece of paper. Okay, let me see if I can find it right here. Nope. Yep. So what you may want to do is simply pause it right now. Write down the definitions there. Remember, the square is the most serious. The rectangle is a little less serious. The rhombus is starting to get loosey-goosey, and the loosey-goosiest of them all is a parallelogram. And don't forget about our lonely trapezoid. So go ahead and pause it right there and copy this down because you're going to need it later on. Now, with that being said, it was great seeing you guys again. Absolutely fantastic. And I hope to see you all in person sooner than later. Have a great day. Keep the feet on the ground. And remain a superstar. Superstars. Have a great day.